Today we're going to discuss equivalent systems of forces and moments, which are a helpful way to think of systems of forces and moments. So I have a system of forces and moments over here. We have a horizontal bar, which is 2 meters in length. We have one force of 10 newtons acting at one end, and we have one force of 5 newtons acting in the middle. Also, we have a couple of minus 25 Newton meter acting. Now, needless to say, this is a body and not a particle, since one, it has finite dimensions, two, the exact locations of the forces are important, and three, there's a couple acting on it. Now, the question in front of us is, if I want to apply one force and one couple at this point, which I have marked, I can mark this point or any other arbitrary point, can I have one force and one couple acting over here and still ensure that this bar will act identical to this bar? So let us depict this one force and one couple by F equivalent and this one couple by C equivalent. So what is the value of F equivalent and C equivalent such that this bar behaves absolutely equal to this bar as far as mechanics is concerned? So the answer to this is fairly simple. F equivalent is simply equal to sigma Fi, which is the vectorial sum of all the forces acting on this bar, which in our case is 10 newtons plus 5 newtons, which is equal to 15 newtons. Secondly, C equivalent is equal to sigma Ci, which is the vectorial sum of all the couples acting on this bar plus sum of moments of forces. So this we can see, so this sum of all couples, so this is the couple that is acting over here. It is a couple of minus 25 Newton meter plus what is the couple of this force acting about this point, since this is the equivalent point equal to this point, that is equal to 10 newtons into 2 meters, and it will be negative since this is clockwise, so that will be minus 20 Newton meter plus similarly minus 5 Newton meter, since it's clockwise, 5 into 1 minus 5, which is minus 50 Newton meter. So basically, if we apply a force upwards of 15 newtons and a clockwise couple of 50 Newton meter, basically a counterclockwise couple of minus 50 Newton meter, this bar will behave identical to this bar. So this means that these two force systems are equivalent. That is, as far as mechanics is concerned, these two force systems are identical, and these two are not the only equivalent systems. If suppose I had done the same calculation but about this point, then I would get a different system of equivalent forces and moments. So this will be F dash equivalent, and there'll be a couple acting over here which will be C dash equivalent. Or if we took this point, now I'll leave it up to you to calculate the values of F dash equivalent and C dash equivalent for say this point and this point, and this basically is equivalent systems of forces. Now let us see how this concept is actually useful. So what I've done is I've made these two bars. Again, these two bars are supposed to be identical. So 1 meter, 1 meter, and the question that we've asked is that this is a system of forces that are acting over here, and over here I've drawn an equivalent system of forces about the midpoint. The question that is asked is, what force and what moment do I have to apply at this bar so that this bar is in static equilibrium? So let us draw our example forces at the same point, just slightly displaced so that it's easier to make. I have a force named F1 and I have a couple exactly at this point, which is C1, and these forces and these couples are in such a way that this body is in static equilibrium. So let's just go ahead and apply our conditions of static equilibrium. First of all, sum of all forces has to be 0. So 10 newtons plus 5 newtons plus F1 is equal to 0, which gives us F1 is equal to minus 15 newtons. Secondly, now that we have all the forces equal to 0, then we just have to find out the sum of all moments and sum of all couples about any convenient point. I will choose this point, since then I will not have to calculate the couples of these two forces. So let's calculate the sum of all couples. This couple is minus 25 Newton meter. So minus 25 Newton meter. What is the couple of this force about this point? This force about this point is minus 10 Newton meter. 10 Newton into 1 meter, and since it's clockwise, it's minus. So minus 10 Newton meter plus C1 is equal to 0. So this gives me that C1 is equal to 35 Newton meter. Now let's solve this question in a different way. Let us calculate what the equivalent system of these forces, this 10 Newton force, the 5 Newton force, and the 25 Newton meter couple is at this point. So what is F equivalent? F equivalent is 10 newtons plus 5 newtons, which is equal to 15 newtons. And C equivalent is equal to 25 Newton meter negative minus 25 Newton meter. And what is the couple because of this force about this point? Minus 10 Newton meter, which is equal to minus 35 Newton meter. So what do we magically see? What we see is that F1 is equal to minus F equivalent, and C1 is equal to minus C equivalent. Just go ahead, take any point. Take this point at over here in the middle of these two marks, that is at 0.5 meters, or this point, which is 0.75 meters, and you'll see that this identity is followed. Basically, there is no reason for it not to be followed. Why? Because earlier we said that these two bars are identical. As far as mechanics are concerned, these two bars look completely equivalent to each other. So we can intuitively see that the force that is required to keep this bar stationary, the force and the couple, is one which is identical to magnitude to this equivalent force and equivalent couple, and opposite in direction, which is exactly what we have over here. So this is how equivalent systems of forces and moments are useful. They're useful when you have to calculate the force and the moment required to keep a given body in static equilibrium. I will continue to use this system in solving problems, and this will get more clear then. Please solve this question so that we can evaluate the efficiency of this video. Thank you.